See, once again here once again, see, this is the amplitude now. So we know that I naught is equal to what? A square. So I is equal to, we are just squaring this whole thing. So we got this. No, this is A naught, A square is equal to I naught, and cos square 5 by 2. What is cos square 5 by 2? 1 plus cos 2x by 2. 1 plus cos 2x by 2. So when we solve it, we got this. When we further solve it, 2 and 2 will go away, and you are left with 2I naught. Okay, cos 5 will remove it. This is the average value. Okay, got it? So for the first case, we got 2I naught. In the second case, it will be 0. When the intensity, when amplitude is 0, automatically intensity also will become 0. Okay, so that's the answer. Clear? Is it clear all of you? Yes, Dhruti, Moksha, and Ismail. Is it clear, this concept?
Yes, sir.
Okay.
Yes, sir.
Try to learn this concept clearly, because there will be a numerical also from this. There can be a theory question also. You didn't know today? There. Alan. So here, if phase difference is phi is equal to 0, comma plus or minus 2 pi, comma plus or minus 4 pi, that is said to be constructive interference. Constructive interference. Okay, so suppose if here it is phi is equal to what? Phi is equal to, we have plus or minus pi, comma plus or minus 3 pi, comma plus or minus pi pi. That is said to be destructive interference. Said to be destructive interference. Okay. And if the phase difference is 0, 2 pi, 4 pi, that is constructive, and pi, 3 pi, 5 pi, that is said to be destructive interference. Okay. Now, next is what? Position. So where it is found. Okay. We'll see about the position. So for constructive interference, it is also known as bright region. Constructive. Means suppose what happens is, on the screen, the lines are forming. Suppose this is the central line. Okay, like this, we are like different lines are formed. This is central line. Like we are getting the lines like this. Okay, first, second, third, and first, second, third, like that. So that is said to be what? Constructive interference. Bright ones are said to be constructive interference, or also known as bright region. So what is the formula? X is equal to xn is equal to what? N into lambda capital D by small d, where n is equal to what? 0, comma plus or minus 1, plus or minus 2, keeps on going. Next is what? Destructive interference. Destructive interference. For a destructive interference, we have dark region. It's also known as dark region. Dark region. So that is what? X is equal to what? X is equal to xn is equal to x plus 1 by 2, n plus 1 by 2 lambda capital D by small d. Lambda into capital D by small d. This better I think I have to explain this after the better I'll explain this concept after the interference of light. Okay. And we have fringe width also. N is equal to, we have plus or minus 0, comma plus or minus 1, plus or minus 2, keeps on going. This is the next one is fringe width. These three are important. Fringe width. Fringe width formula, what is that? Beta is equal to what? Xn plus 1 minus xn. That is beta is equal to what? Lambda capital D by small d. Lambda into capital D by small d. This is the formula for fringe width, that is beta. So this is for the constructive. Keep this in the mind. What is the phase difference for constructive? 0, 2 pi, 4 pi constructive. For destructive, pi, 3 pi, 5 pi, that is destructive. I'll remove this one. I'll explain the Young's double slit experiment. Okay. Young's double slit experiment. In Young's double slit experiment, interference of light waves. Interference of light waves. Drop this one also. Interference of light waves. Young's experiment or Young's double slit experiment. Young's experiment. So here we have what? We have here now. The third one is this is the so here what is that? This is S. This is S1 and this is S2. Now zero and this is 0 and 0.2. So this distance here, I'll draw one more diagram here. So if you see carefully, this is S1 and this is S2. This is these two waves are meeting at this point, and this distance is said to be capital D. This distance is said to be small d, and this is said to be xn or x. Okay, x, and that is a screen. OGG dash. G dash is the screen, and O is the center. Is that clear? D is the distance between the two slits. D, see what happens here. This is the source bulb. So what we have done, this Thomas Young at that time, there was no light and all. He took the cardboard, he took the candle here, and he took the source. This is the first cardboard, this is the second cardboard. So the first cardboard, he made one hole, and the second, the light came out, and the division of wavefront took place. Division of wavefront. Then what happened? These two waves, two sources formed. These two sources are said to be coherent sources. They are said to be coherent sources. Coherent sources means which are in the same phase or constant phase difference. So again, after that, the screen, the light, the pattern is formed on the screen. So at that time, we did not have laser. Now we are doing with the laser and all, because at that time there were no lasers and all, or no other sources, current electrical sources. So here, the same thing is explained here. S1, S2, small d is the distance between the two slits, which is in millimeter, micrometer, nanometer, very, very small. And the distance between the slit and the screen is how much? D. That is maybe 1 meter around, 100 centimeters. And the distance from the O to G is what? X. So there's a formula. Okay. Now here, so I'm just writing here S2P minus S1P. So S2P minus S1P is equal to what? N lambda. S2P minus S1P is equal to N lambda. So, and also N is equal to what? N starts from 0. N is equal to 0, 1, 2, dash, dash. Keeps on going. Now x comma d is much less than x comma small d is much less than d. That's the value. Clear? So now after that we have, see, we are not going to do derivation because he is asking qualitative explanation for this in the syllabus, not the quantitative. Quantitative means a whole derivation. The derivation is not being asked here. So what is that we are going to do? The position. The first is what? The constructive interference. Where is the constructive interference formed? Here on the screen, if you see, this is the screen. On the screen, you get a bright and dark fringes like this. We get a bright and dark fringe like this. Okay, bright and dark equally spaced. Bright and dark fringes equally spaced. So the constructive interference of the bright region or the bright fringe is found where? When x is equal to xn, which is equal to n into lambda capital T by small d. N is a number, that means whatever the number you have, 0, 1, 2, 3, 4, and lambda is the wavelength of light, which is in nanometer or angstroms. D is in centimeters or meters. Small d is also centimeters or meters. It is very, very small. This is for constructive, and this is for destructive. Okay. And what is the fringe width? So fringe width is the formula. Fringe width, the definition of fringe width is distance between two successive bright fringes or dark fringes. Distance between two successive bright or dark fringes is said to be fringe width. So beta is equal to xn minus 1 minus xn. If you subtract both of them, you'll get this formula. Lambda into capital T by small d. These all three formulas are very, very important. Okay. So quickly we'll do some numerical on this one. And also I'll tell you the pattern how it is. The pattern, if you draw the pattern, how it is, I'll just draw here the interference pattern. This is the interference pattern. All are having the same intensity or same amplitude, I mean. Okay, all are having the same amplitude. Now here, what is that? This is path difference. This one is path difference. Path difference means because of the path followed. Okay, so what happens? Now suppose both are moving in this way, they are meeting. But sometimes it is going like this, right? So if the two rays, suppose these two will come and meet here, it is same path. But this is going and meeting here, and this also coming here. Here they are meeting. Then this length will be more than this. Means the path followed by this is more than this. Okay, so that is said to be path difference. How much difference in the path? Is that clear? Like suppose I'm going from Sharjah to maybe Dubai. There are different roads. Like one road is, I have Gises road, I have one Salik road, I have different roads. So the distance, the path followed by the other road is more. Gises or Emirates road, if I go, it's lengthy. Same way. So because of the path, like see here, this has a big path, a small path. So definitely there will be a path difference. Is that clear? Now, so that is what we are saying. Path difference. Central one means 0. This is I. I is the intensity here. Okay, I is the intensity. So how it is now? It is 0. This is lambda. This is 2 lambda. This is 3 lambda. Sorry, 2 lambda. Then 3 lambda. Here also lambda. Then 2 lambda. It keeps on going. Understood now? Lambda, 2 lambda, 3 lambda. That is a path difference. Is that clear, all of you?
Yes, sir.
Okay. Please copy this one. Then quickly we will go to the